All right, should be live, and welcome back. Last stream I was working on the clock driver for Linux, not the clock driver, the clock gate driver for the M1 for Linux, and that was pretty easy to write. But I want to understand the power management block that these clock gates are part of a little bit better. So I have a dump here of the hierarchy of clocks that Sven sent me, and he doesn't remember where what what code generated this, but this is not the only structure that is involved. So if I look at that, so I have ADT here. If I go to PManager, you can see that there's a whole bunch of like blobs that have structures in them, and so the one that that info earlier came from should be this one called devices, I believe. Let me find that. Should be eCPU 0. Yeah. And so basically I want to do, before I submit the clock driver, I want to make sure that I understand how this works. So I'm going to add parsing for these substructures to my ADT parser. And then I'm going to make a pmanager tracer for the hypervisor that shows me what macOS does with these things. Mostly to confirm what I already know, basically, about how the clock gates work, but also because I'm curious about what other information is encoded here. Because people are going to ask us, well, what frequency are the clocks and stuff like that. And it would be interesting to know, like, there's a clocks thing here, for example, right? So it'd be interesting to know if there's any, easy to get information about this that we can say, or at least, something. Basically, I just want to know more about how this works. So, yeah. So the first thing, and this is, by the way, the like work in progress driver thing that I have. So this was written by Sven, and then in the previous stream, I basically reworked it using a different approach that is actually this is part of some discussions we had on IRC about different ways of doing this. So I don't know if this is going to be the way that we end up doing it in Linux, but it makes sense to me. So basically what we're doing is this. What we're doing is having a pmanager that is actually a syscon type device, which is a basically a device that contains other sub devices that do different things. And so this is a standard Linux driver that doesn't do anything. It just maps. It just gives other sub devices access to. It's basically having multiple smaller drivers for one big device. And so in this case, we actually have one device/driver for every single individual clock, and that just makes life easy when declaring which clocks are dependent on other clocks. And so that's sort of, this is one of the outcomes of discussions we had on IRC and the previous clock upstreaming like review on the kernel mailing lists. So, but like before I submit this as is, which is probably going to be fine anyway, I just want to double check that my understanding of this is correct. So yeah, let's do this. So the first things first, here in the mini ADT parser, I already have a a function here that parse prop that is in charge, and build prop. So these two functions are in charge of formatting and unformatting these things. So do I have any other devices property? Yes, we do. So we need this to be specifically on pmanager. So basically, like that. And let's call this a actually, you know what? I might want to do this with a bit of something like this, and that way we can do it. So node, we do have node name. Actually, do we have node name? I'm not sure if we have node name because of I might not have it. But we have the path though, so we should have node name. Just remind yourself of how this worked. So it does a parse prop, but it doesn't actually set the name. So we probably should do that. So let's do it like this. Or is it just name? Hold on, remind myself of that. Yeah, that just goes through properties, but we should probably set it here. And name just gets... We had a name thing, right? I think so. Name... Yeah, self-name, which comes from where? Oh, I just realized I don't remember where this came from. Hold on. Is self-name even set anywhere? Has to be. Huh? Hold on. What? See, I love it when code looks like it shouldn't work, and then it does. Where's my ADT stuff? Some old ADT. Where's that thing? Event data ADT, something def after I boot. Yeah, that's fine. This one maybe. Okay. But that doesn't make any sense. Yeah, self-name. Oh, wait. Because properties are resolved like with dot. That's why it works. So as long as I set, because we have get outer, that's why. So as long as I set self.properties, as long as I preset that to name, then we're good. And in that case, actually, we can just do with path is self.path, and it'll work. So let's see. So we have pmanager. Node path name v. So if node.name in def properties. Actually, it's like this. Path. do it like this actually. If name in dev props, in dev props name. Cool. And in that case, then all I have to do is devices, manager devices. Equals struct, and so here actually would be greedy range. Range? Yes, it is. Range of struct. 1 second, just got a notification. Sorry about that, it was a work thing. Okay, so we got this. So, let's see. So the structure there was, looking back at the ADT, it is basically, there's 1, 2, a bunch of things, and then let me just text dump this, a bit of this. Yeah, I thought so. So looking at this here, we had 2, 3. Yeah, so this is the address. This is the physical address. Hold on. 2337 flags 2000. Yeah, so this is flags. Okay, the address is just added then. So it should be 08. Huh, that's kind of weird. 5. It was just an offset like in 8, 10. No, 5, 6, 7, 8. That's kind of weird. 5, 6, 7, 8. 31 to 34. And then there's a jump here when the device is. Let's see. There's 1, 2, 3, 4. So we have the indexes there. Those are the same as these. Where's the offset in the register though? Anyway, for now it's clear that it's let's just call it 8 uint32s and or something like that. And then let's see what happens. I know I had this structure somewhere that's meant to be. I forgot where it was. But anyway, so let's just say. Actually, the parents were definitely in there later anyway. Ah, yes, thank you. Sven just sent me the right thing. Oh yeah, it wasn't mini. I'm dumb. Flags parent and then address offset. Well, it's not counting that. PS reg index. Okay. Thank you. Let me just copy this then. We don't know what this is. And then, actually, these should be we know we have at least probably 3 parents. I'm guessing that. I don't think we saw anyone with 3 parents, but that's probably what that is. And, then this should be a padded string. Okay, let's see if that process it. Space somewhere, maybe. Hold on. I'm dumb. Slashes. For error path. Oh, it's not node path. It's just path. Okay. To any values. Oh, did I just it's not return, sorry, t equals def props. Aha. And then the building it doesn't work anymore. That's fine. But actually, instance t is not none. No, it should be there. Probably just let's see if that works. Unc2 no, looks like some kind of index 2 or something like that. Let's see. I kind of want to print this in one line, to be honest, but I don't know what the Unc2 thing is. Hold on, can I at least text dump this? Yeah. Unc3 looks like padding. Or not. But it's definitely a integer anyway. I don't think it's anything that ever has to. Yeah, so let's just say Unc3 is an int32 UL. Flag should be hex. Rohit asks, "Am I going to tackle the M1X?" Yeah, of course. We're gonna work on all of the upcoming Apple talks, and most of what we're doing for M1 should transfer to the M1X anyway. Let's see. Yes, yep. It's kind of interesting that how the indexes work here. So the address. address here. Anyway, sorry about that. Just got distracted with some trolls in the chat. So address offset 3. Yeah, that's what I thought. So the address offset is the clock gate thing. So let's rename that as gate off or something like that. Let's go gate index actually. And then actually this some of these have addresses with an 8 in there, and where does that come from? Okay, so psreg index, and then psreg is a separate property called psregs. Aha. And psregs is index and offset. Okay, so 1 and then there's some other stuff in there. Apparently it's 3 words each, so let's see what's in there. Okay. I keep forgetting this is not a dictionary. And commas here. And that needs to be uppercase. Okay, that should work. I want the offset to be hex. And that makes sense. Though index isn't what I think it is, so I'm not sure what's going on there. And what's unc? Actually, that's kind of weird. It looks like length actually, kind of, but then the 4001 doesn't have it, so it's kind of weird. Reg index, 3 times index, reg index, and then we get, okay, so that's the index into the rect table. So that makes sense. The first one is the big range there, and that has those, and then, sorry, this would be the second range, 3D28, was it? No, 3v7 is the first one, but then that's probably the second one coming from here. Sorry, the third one or something. If you go to devices, PS reg index is 3. Yeah, that makes sense. And number 3 is this one, which has index 0. Yeah, and offset 0, so that makes sense. And that does look like a mask at this point. Pretty much. Index 0. Yeah, I would say that's a mask. Though the 103, this is weird though. That one's kind of strange. So this one is number 1, 2, 3, 4, 5, 5. Do any of them have that? Yeah, they do. So like DCS has that. Yeah, that one's kind of strange. I'm not entirely sure what's going on there. The others do look like a mask or length though, mostly. But I'm not sure. Or maybe this has to do with what bits are implemented in the register. Not the address, but rather the value or something like that. That might make sense. Okay, so, and then I'm also interested in this. Like, I want to make some attempt at decoding like this clocks array and stuff like that, because this is all probably related anyway. So let's see. So first of all, why is this not asserting? Output, yes. Let's see what changed. Oh, right. If I put name in there, then the order is different. That's why I wasn't saying the name properly there. So I don't actually do that. Yeah. So that's why I didn't do that. So in that case, let's just pass the name as a thing to the parse prop. properties. Node name, node name, and then path name. Yep, the other way around. Okay, now it doesn't assert anymore, so that's fine. Cool. So, go here, devices. And now let's write some code to dump this out. How do I know this code is going to work? Am I operating with a public stuff everyone can see, or just a private just trust me bro codeways? I mean, like I'm not sure what you mean, but like I'm reverse engineering this, right? So like I don't know that this code is going to work. That's the whole point, right? Is I'm working things out to figure out how it works. So okay, so let's make a, what's the best way of doing this? I guess I want something to dump out pmanager stuff. Maybe just a tools thing for now, and then the pmanager tracer is going to use it anyway. So, so let's just do it like this. We do need that. argv1 rb read, and that is adt. Just load adt. Cool. Was it ARM? I forgot what this was. ARM IO. PMGR. let's pad this out to 3, and this to like 10s. Rag flags. And just do it like this, and then if and then that goes, those are the ID, and then find device, so it just looks up for that ID, basically, yeah. Just call it by ID. Something like that. Flags, step flags, and then, ooh, missing a parent memory. 264. Yeah, huh? Interesting. Okay, so that third one is not a parent because that's clearly not a parent number. And 309. Yeah, that's clearly not. What are those? ISP sense 1 and sense 2, 309. Those are ISP related numbers at least. $264. What is that then? 264. That's weird. $278, $265. Yeah, $278 doesn't exist either. 265 doesn't exist either. 567. It's almost like an alias. Or did I get the ID wrong? No, that should be fine. It's almost like it's some kind of alias thing. $288. Yeah, because they're all like missing numbers, right? Expect CPU 0, 288 and 87. Yeah. But it's also kind of related, right? That's weird. Okay, so that almost looks like it's some kind of alias thing. No. At least we know it's not a parent, because it doesn't make any sense. So let's call that parent 2, but then that's also clearly an index, so... but also it comes before ID, which is strange. Like, what would that be in the array like that? Let's go ahead unc for now. And print it and see what happens. Comma. Okay. And now 81, that's weirder. And 81 is also not there. Hold on. Okay, that is in parents. But that says the parent is 35. Oh, this has it as 30. Am I doing this wrong? No, it's looking for the ID, and the parent thing was looking for the ID, right? So, Ketenis mentions that we could treat the multiple parents as like a parents plus auxiliary, and the clock frequency of the gate clock would come from the first parent, but enabling the clock would also enable the auxiliary clocks. Yeah, I think that's basically what Apple means with the parents. But the thing is, I don't really know why. Like, what does this mean in the hardware for there to be an auxiliary clock? Like if it's just that those clocks go together for devices, then you might as well have them be separate clocks as represented in the device, right? So what's the point? Like if there's a reason for this that makes sense, like that means it makes sense to represent it like this, then sure. But so far, I just don't know that there is a reason, right? It's kind of strange how they do this. And I'm confused as to what happened with this. Because that says it should be 35. And now I don't know where that came from, because I got an A1 here. Yeah, like I want to clean up, well, this isn't much to clean up. I'm going to submit the clock driver, but before I do that, I want to understand the clocks a little bit better, and so I'm just trying to reverse engineer a bit more. Yeah, I don't know where Sven got 35. Maybe it was a different ADT. Or maybe this is old, because this is definitely... this is definitely... how did I do that, by the way? ADT... I know I had a input, output, args question mark, yeah, and retrieve. Okay, so just, yeah, dash R. Let me just do it with the most recent thing. just in case it's like a bug they fixed or something, which is entirely possible. And that should be cool. Okay, that works. Yeah, no, it's still 81. Where the heck did that come from? Is the installer complete? It's good enough for development, basically. It's good enough to make life a lot easier for developers. It doesn't it doesn't, there's no reason to make it sort of, fully end user friendly, because obviously the result in the kernels and what we have isn't really at the point where you'd want random people installing it. So but there's not a whole lot of work left to get there. So basically what we have now is good enough for making our lives easier. And once the kernel drivers get to the point where we would encourage people to try this, then I'll just make a few extra changes and make it a bit nicer for users, and it'll be cool. Yeah, I'm just going to I'm really confused by this, but okay. I do need more padding here. And probably yes, the a bit weird here. I think I need to clear the console has a problem with very long lines and rendering being kind of horrible. So actually, let's just zoom out a little bit. Probably want this UNC thing padded too. That's weird. 268. So they're all numbers that come afterwards. I wonder if it's an index into some other array. Wait, because this goes further anyway. This goes to like 400, and this doesn't go to 400. So did those come from a different device? DP1 stock VNAX? .403. Da, da. SOC VNAX, DP1 SOC VNAX. No, that is 403. Oh, yeah, sorry, not yeah, it is 403. Sorry, I'm dumb. Those are the index keys. But then hold on. 280, 73, 282, 290, 300, 301. Interesting, because these numbers start at no, there's a 264, sorry. $258. Let's see, that says ATC USB0A on there. I really wonder what that number is. And then what about the parents that we weren't finding? There was one. Yeah, what the hell is that? C0 USB CTL. Yeah, it just has like no parent listed here, but what? Is that just a bug? It might just be a bug though. That might just be that they fucked up. Either that or it's defined somewhere else. And there's like a because we have bridge counter, event, device bridges. We have 2, whatever that is. Yeah, so let me just think about that for a second. 81 is 51. Is that anywhere? No, actually. So, yeah, there isn't even. So yeah, no, that's not a listed ID anywhere. Maybe that's just a bug in the ADT. Would not surprise me, because everything else makes sense, except for this. I really want to know what that is about. Very first one is 258, which is does exist. ATC USB Aeon. It doesn't make a lot of sense that has anything to do with SBR. What keyboard am I using? It's a Philco Majest Touch, the full version, with Cherry MX Brown switches. Yeah, like I know I have I do use a 4K thing, and I try to keep the text a bit larger than usual, so it's readable at 1080p. But if you're watching it anything less than 1080p, it's definitely not going to be readable. Sorry about that. Like, I kind of need to balance the the viewability on the stream with being productive with with enough things on the screen. Yeah, detecting intended behavior versus bugs is always fun. And sometimes you find out that those little things that don't make sense suddenly make sense in the end, and sometimes it's just it's just nonsense. I mean, it's weird because it's like the one parent that isn't listed. What? So, yeah. Oh, here's one that has one nub SPMI 1, but that doesn't make any sense for it to be ECP 0. So maybe it's an indicant to something else. Okay, so let's look at the other arrays and see what else is in there. So we have bridge counter configs, which sounds kind of fun. Device bridges. And then reg. Clocks is interesting. I want to know I want to know how clocks is encoded. So let's take a look at that. Let's just do it here anyway. we go. So that is something, something. These look like bytes. That looks like the first one is an index. Or something like that. And then we have a 16-byte string and some other indexy thing. Yeah, so basically 4 bytes. What looks like padding because there's nothing else there. And then, okay, let's try that. Probably index. We'll see. I think fast AF means fast autofocus. Is my guess. That it is a camera thing. Know what those are. And then there's another one at the end with like 2 more of the indexes. And then another padding thing. So this is a 32-bit, and then we have a name. This is again a 16-byte string, and then another for whatever this is. Let's call it like this for now, and then some other unknown padding, just to see what goes on here. And then let me make sure this actually parses first. Yeah. A bit shorter here. Call that ID, possibly. And then let's just say A B C ABC W X Y Z, and that's, yeah. Just to make sure that something like that. And that's name, clock name. Huh? Oh, I don't have it yet. Okay, almost there, but not quite. Four 32 bits, 16, 4 32 bits. Oh, I'm done. It's just that 432. Sorry, I'm like offsetting myself here. It just ends here. PMGR was not getting used because I didn't add it, but now it's here, so now it's going to get used. Okay, cool. And then not container, clock on clock name, ID, ABC. Oh yeah, sorry, don't need that anymore. Cool, there we go. So those IDs are definitely separate from the others. And we have 2 different numbers for it, actually. So ID could be something different. So there's an index later, 1, 2, 3. That looks more like the ID. But then 54th, and then it starts at 20. AOP clock, but doesn't have anything to do with PCI, so that looks like something else. That might be an index into the register then. And that also looks like possibly the 3rd number is, or the 1st and 2nd number are like register indexes or something like that. That would make sense. So then I wonder if any of these are also listed here, or if there's something else. And like this is clock cell, it says, so it looks like this would be a clock select or something like that. So let's look at this again. And what other things we have. So bridge counter configs, events. Device bridges is kind of interesting, but it doesn't have any strings. It's just a bunch of numbers. And I wonder if that references devices, it'd be kind of interesting. And then we have power gate regs, perf regs. Let's see if these are also kind of like the PS reg structure, which I also should print anyway. PS regs. Yep. And offset is apparently has some more digits. And this is actually the reg is what we should be calling that. I just wondered how will Linux schedule tasks on the 2 different types of cores, high and low performance, or would treat them as the same? A lot of people have asked that question. These Linux supports devices like this and has for a long time because it's the same thing that's in Android phones. So we actually, it's not specified in the device tree yet, but there's actually a thing here where you can set basically what the relative performance of the different cores is, and then Linux knows to use that to calculate where things get scheduled. So this is already a thing in Linux, basically. That's kind of interesting. The offsets we have here. T8, 4. This is kind of weird. And I do remember that I think that different ranges of PS regs had like different values. So I'm going to do a quick check on that actually. Actually, you know what? I'm just going to read them. Address should be pmanager.reg. It's PMGR.psregs. PSReg index, and this is PS dot PS ADT. PS regs reg 0. Actually, did I tuples? Forget if I had named ones for that or not. Reg. Oh yeah, I did have address and size. Address. Plus PS dot offset plus gate index times 4, I think is how this works. Something like that. That is not quite right. Some of it is right. These 58 ones aren't right. Did I at least get those right? The same as Sven's thing. 8, 10, 3B7, yeah, those look right. And like, I just 2C, 200, yeah, those look right. And then the ones that have zeros are these, for example, which have gate 0 and PSREG 0. But is PSREG 0 valid? Because like there's this. And debug is only 0, 0. Or maybe there's a flag for this. That says that that is valid. Or that it isn't valid. Is there anything that correlates with that? The first ones. Gate 30. Maybe the 1 there? No, that's different though. Does those look valid-ish? Maybe the 0, 0 is not valid? Gate 0 on a different PS reg is a thing or not? Maybe just gate 0 means... yeah, maybe just gate 0 is... No, here's one with the 0, 9. This is... PS reg 9 is not used anywhere else. Yeah, that does get an address there. I do kind of wonder, is this a thing? And also, this isn't I need get-reg on this. Let me do it like that. Yeah. At least I should be able to read all of these offsets, even if some of them are like nulls. So let's do a bit of mini setup here. Stumpy manager. There we go. And I want x. Actually, 10x. Yeah. Okay, my zoom isn't working now. Oh, is it still doing that again? I think so, yeah. Okay, let's scroll back. PSReg 11 has FFFF, yeah, and then these, like 4 has FFFF. 5 is E0BF, whatever that is. And is the one with 12, for example? Ah, but it's different though. Yeah. Interesting. 0, is obviously bullshit. So in the case of 0, the parent is just a clock that needs to be enabled before this clock works. So sometimes they need to be enabled for the clock to even accept being enabled, and sometimes it just means that it won't work until it until it actually enabled it anyway. If that should be how many spaces? Not sure how many spaces. Just wing it. Oh, one more. There we go. 425. So this is also kind of interesting. For example, here's a clock that is supposed to be enabled, but isn't being enabled. Because otherwise this would be F. But Yort1, I don't even know if Yort1 is used. So that's another question. It could be that that's just not gated somewhere else. But then again, this claims to only have one parent anyway. I really want to know what this unknown index is. It's clearly an index into something. 305. Some of them exist, right? But like JPEG sock Vmax. And then 305 somewhere here. Yeah, like ANECs doesn't have anything to do with it. So it's clearly not an index into a clock. Gate. 1, 2, 3. Three oh eight 9. Yeah, it's going to be another array somewhere. So what about these, for example? These like 21 through 25, is that mentioned anywhere on the AOP stuff? So the yank. The yank is interesting. Number 7. There shouldn't be that much stuff there. So this 8, this sounds like a PS reg. Which makes sense. So let's look at another one, for example. Oh wait, no, that doesn't make a lot of sense though, because these are just increasing. So that doesn't. Maybe not, because those are just indices. But the ink is an 8 there. What about, but maybe it is though. Maybe it's just that those are, the PS regs are also the clocks. That would kind of make sense. So let's look at something else. Let's look at this. Claims to be 3. Oh, well, you have a 5 there, so it doesn't match. What about PS regs? No. Let me try. And there's also these random like numbered PLLs that don't go anywhere. Let's try A&E. I don't know if there's some relationship between these things or not, but also there should be a thing here. This is clock IDs and clock gates, right? So this should be the ID of the clocks we're looking at, hopefully. So that's kind of weird. One something A1. First of all, let me make that property do something sane. So properties clock IDs should always be a greedy range. I think 32 ULs. Yeah, 320, 320, 322. Interesting. So clock gates is 302, and then we have clock ID is 320, but that's outside of the range of that. It is 302. It needs this V. Okay. And then we have clock IDs 320, which is missing. 321 and 322, which are not indexes into this, obviously. Interesting. Where are those IDs coming from? But is it... No, it still doesn't make any sense. Hold on. 332. Sorry. 140, 64. It could be these three, though. It could be that that is... It could be that this is a... Yeah, that does kind of make sense. That is a 16-bit number. And then this could be something else. So in that case, clocks A would be... So that the ID would be something else then in this case. The ID would be, yeah, 16 UL, which makes sense as the first thing there. Let's call that AB, and then here we dump the clocks. Just do AB and UNC. Yeah. Okay, so in that case, okay, so now we have 4, which is not present, but then we have 335, which is also not present, so that's not looking good. No, that's not looking good. 269, 284. Nope. Let's see. So looking at SBR here, that has a 258. That would be 256 plus 2, which does match that kind of number there. Kind of. But it's a bit of a stretch. And disp 0, I don't think matches that. '87, '88, '89, '90. That's not quite what I want. What other properties are in PManager? Let's see. Bridge counter configs doesn't quite look like it. Events doesn't quite look like it. Device bridges is interesting. I want to know what's going on there. PowerGate regs, perf regs. I definitely want to decode PowerGate regs. What's going on here? Okay, so those are 16 bytes each. Again, we have something, probably an offset, and then, or like 3 values there or something, and then that kind of a mask thing, and then, okay. So that might be reg, which kind of suggests we have multiple instances of PManager. And then, is that an offset? I'm not sure that makes sense as an offset, because I don't think regs go that high. Reg 1, no, in fact, reg 1 is, no, sorry, here. Reg 1 is 7.4. Oh, no, they do go that high. 1C0, 10, CC10, 610. That does look like some kind of range with power gates. And then that would mean that we have like 2 different PManager instances or something like that, which is kind of makes some sense. So it's probably reg, offset, mask, and then something. Let's call this mask or PS regs. It's obviously a mask of some sort. And skunk. Okay, looks good. Is it possible that this is just the clocks and something else? Because those numbers, the ones that don't have like 256 in them, could you kind of look? But then these are weird. Like 300 is what? 12C, which is 44, which is longer. But like the ones that are less than that much do look like, hold on, EFP clock 2015. Those could be PLOs. 17, PLO graphics. No, SMC fabric does not match that. I'm not confident at all about that ID thing here being 8 bits anymore, so at least I'm going to hex this. $147. And do this unc thing as a hex 2. And I want that as like 5x then. $12. So what else do we have? Device bridges, perf ranks. So hopefully those aren't related. Power domains sounds useful though. Let's figure that one out. So, that starts with, again, some kind of 4 bytes of stuff. The second one looks like an ID. I wonder what the first one is. It's always 0, apparently. 7, 9, okay. So, unc 8 well ID. E is probably some kind of index or offset or something. And then it's just the string and that's it. Here. And it's unc ID A. A off and unc. That did not work. Why did it not work? Because I have another padding thing here I didn't add. Okay, that looks reasonable. And I feel like I've seen those numbers before. 4A, 4B. Let's do this integer. 74, 100, okay. ISP sends 0, and he says, no, that does not match. Avery asks a total noob question, what is the clock required? I'm not sure what you mean. What is the clock used for? These are the clocks that drive the different parts of the chip. So you turn them on and turn them off to save power, basically. But if the clock is off, of course, whatever part of the chip you're trying to use doesn't work, so... Mm-hmm. It's also possible that these just match up with this by name, but it's kind of weird. So, like, this is 142. Then this is 83. The clock driver that already works is required to get NVMe working, yes. But that already works. The thing is that before I submit it, I want to make sure I understand how this works. I'm spending some time just looking into it. Okay, power gate. That might be... Yeah. No, it's just that, but... Oh, no, there's a separate power gates thing. Okay, so that just references those in that case. But let's see if it actually does reference them, because I'm not so sure anymore. Clock IDs. We have clock gates. And power gates. Yeah, 77, 97, 29. Do those match? Yes, they do. Yes. DCS40, whatever that is. EPCIe? I don't know what DCS46 is. Ooh. But then there's 347 again. I get the feeling we're missing something here. Like, hold on. Do any of the others match? See, we're back to big numbers again. That doesn't make any sense. Power gates, none? Okay. That actually is kind of a bug. What happened there? I feel like if it's empty, then it doesn't do it. Oh, is it just because if it's not? Yeah, okay. If it's empty, we return none in that case. But that's, I guess that's okay. 77 and 729. 292. Something easy to SIO. Is there an SIO thing somewhere? $292. But that is okay. So that is actually listed here. So that does power gates is also referencing this devices thing. Clock gates, okay, so it's the same. Yeah, power gates and clock gates 292. So it means that these are used both for clock and power gates. And the gate and PS reg are then for clock gates. But then the question is, where is the? Well, there isn't even an actual clock gate here. There are 3 clock IDs though: 332, 333, and 337. And then SIO, but that's not in the power domain thing though. Let's see, find another one. Dart SIO is 321. Yeah, which again, this thing. And it's interesting because it's very simple. Oh no, 3. Yes, it's ANS. Okay, that could be useful. ANS is 103. Gate 3, so that has both the gate and the stuff, but that's the clock gate though. ANS 2 here has a 101 and 17. That's number 15. That is weird also because it's a PCIe ST is the power gate on the clock gate for ANS, which is see, that doesn't make any sense, right? Like that looks like it's just their organization, their naming scheme being weird because if this is the ANS clock and then this is the like APCIe storage. See, this is why I think the parent thinks it's bullshit, right? It's like, okay, APCIe leading to APCIe storage makes sense, and ANS2 is the actual ANS thing. But then why is APCIe storage depending on ANS2, and then ANS depends on APCIe storage? Like what? That doesn't make a lot of sense. Maybe it's an ordering thing, but for me, it would make more sense for the this to be expressed as ANS having 2 clocks, the ANS2 clock and the APCIe storage clock, which then depends only on APCIe. Which is actually how I did it for the for testing the NVMe drivers. So, but then clock ID is 386385384. Where does that go? $18,012 24. That's a power domain still. Clocks. And then what is on with that? ADMAC power gets 47, which is missing. Oh, that's a ADMAC SIO power gets 47 and 344. SIO ADMA, yeah. Audio PV. Okay, these two being consecutive and these two being consecutive is suspicious. 60. And then we have 15 and 16. Is there just a big offset here somewhere? Oh, like minus 15. EISP. What about graphics? Is that also consecutive in somewhere? Yeah, it is. So, is it just an index? That's so weird. The offset is something like that, right? But so far it fits. It fits as being a reference to a power domain. Yeah, 128. And then we have 127 to CP3 GP. Oh, but that one doesn't make sense all of a sudden. I wonder if there's another list involved somewhere. These are all consecutive. Maybe there's another mapping. Now maybe it really is just by name, which is possible. No, that does kind of match up though. Like it's 199 offset, and the 129 of graphics. Almost. So that sounds like there's another list somewhere that is relating these things. Or that was an index. Graphics. Ah, maybe it's just an index. Okay, so how about 129 minus graphics is 12. And 11A minus 6. Nope. It's got to be some relationship, though. 11A minus 83. ABC, 001 PPP. Yeah, they're consecutive. And then like 11E is not right, yeah. It's got to be another table. Let's look at the other tables. Device bridges sounds like it could be interesting. Let's see what we have there. Okay. One, two, one. Oh, interesting. There's some links there. And that suggests each element is that's kind of nasty. A B A B C D E 4 4C bytes long each entry. Yeah, each entry is 4C bytes long, and then there's some kind of these are big endian, which is a very device tree thing-ish thing to do. But then like the next number is like little endian, which is weird. Is that how it goes? Are you mixing endiannesses? FE 10F. No, it's just that these are 11, 12, 13, 14. It's just that this is another list. So it's actually a list of things. F 10, 11, 11, 12, 13, 14. Okay. Device bridges. So I'm guessing that's a big endian number. It would be and then I need one of those zero padded arrays, which I think I had a definition for in the past. Or it can just be padded though. Yeah. Padded to 4C, so 4, 8. think something like that might work. No, not greedy. It's just array. Actually, since we're just dumping it, we just do it like that and we deal with the padding later. Yeah, it's just annoying. (15, 14, 16, 15, 16, 17). That's kind of weird though. That's not very useful either. Okay, what else is in there? Can I make this list a single line list? Where's that thing? I hate Googling for construct stuff because it's ungoogleable once you get into like any any like details. I'm looking for some of the libs and stuff. Was it formatter or something? No. Inline or something. I think there was a thing to print them as one line. Adapter. I thought we had that, but maybe not. Track default. Maybe not. It's not there. Where is that? Here. Computed constant rebuild. Actual arrow this pickled. Item sometimes some hex dump. Nah. Not terribly useful. I think I'm just gonna hex dump that because it doesn't matter if it's bytes anyway. So let's just say it's bytes of 48 and hex dump it. Bytes bridges, yeah, it's a little bit less annoying now, but I still don't know what that is. Actually, have until 1314. Arcade regs. So what else is in here? AP wake sources, that's hopefully not related. Bridge counters, I wonder. Energy counters is also another interesting thing. What else is in here? Perf domains. Events. Clock tuner. PM. I wonder about this one. Client powers, client budgets. It's got clients or a specific CLPC, NAND, and HDM come in. Could be that these are really just rated by name, which is fine. But these are kind of interesting, right? Sorry, dump these. Don't actually care about that too much. 0, 2, 1, 3, 4, 6, 5, 7. So these are like shared, right? Then these are D, E, F. Yeah, see, that's weird. And then 4, 6. These are consecutive and they're not jumping. And this is a good test. Because these are consecutive here, but should be pairs here. And yet there's nothing that looks like that. They're ordered right, though. 0, 2, and then 1. And then 4, 6, and 5, 7 like jump suddenly. In both places, there's this ID here and this one here. But this doesn't jump, though. CS4, 6... I wonder if it's possible that stuff is just hard coded in the driver at some point, and and like this, the information isn't in the DT, which could happen. I don't think it's going to be the events. Okay. Asahi vendor bins extension. So 0 beta 3 should be good enough. And then the P manager should be in here somewhere. Maybe. P manager, yes, P manager, text, contents, macOS. DCS. See if there's anything interesting here. There's a lot of stuff. Yeah, like for example, some of that video clock stuff. Look, it looks like it's forced or whatever. But also, that's probably done by DCP anyway, so we don't care. Doesn't look like there's any obvious tables here. So, they just index separately then. Hold on. MCC DCS. I like how that's just underscores and this is dashes. Lovely. GP0 and GP1 PPP. CP, yeah, CPU. So these are all consistent. and it jumps after CPU. GP0, 119. Yeah, okay, so it can't be this because that's not. So it has to be the ID. Yeah. And then after that, you have ELC and BRC, which are jumps, right? That gets CPU is 82. And BRC. Okay, so that is the same offset. That is 199. So this is consistent. So let's look at the other ones again. Let's look at this next. PPP. Yeah, it's still 199. Okay. What are some of the other ones we had? SMC. Let's see, that is not correct. SMC CPU is like 10 here and 31 here. Doesn't make any sense. Before this 082, we had like a DCS is. And after that, there's like ISP. See, that's 202. But something got inserted, so. There's clearly another table somewhere relating these things. I wonder if it has to do with the PSREX somehow. Wait, hold on. No. It can't be the PSREX because those don't even have one. And it can't be the name because then this doesn't match. Seven. Six and seven. 728. Is that a thing? AOP. Yeah, that is AOP CPU. PCB and AOP filter. AOP SRAM. But then we go to like a. There has to be another table somewhere. Unless these are referenced elsewhere, like gate index, huh? Maybe that's what it is. Hold on. I think that's what I was looking for. Wait, no, that doesn't make sense. That doesn't read it. ID 29. Power gates, clock gates. No, because we know those are. So, but about like the 25 there. PCPU 29. Let's search for 29. No, we have anyway. Yeah, that's what it did. Nothing there. CPU 88. This is very confusing. Uh, 19. Yeah. That there. Oh, interrupt parent is that. That's annoying. Graphics is 925. That does not look like that. Or 5F is 351. Or an APC, which is wrong. Graphics. look at these three, right? 32, then it's like 9AB. Hmm. Okay, so hold on. First of all, I'm going to do this with decimal again, just to see if any of that makes sense. I feel like there's another structure in here that I'm completely missing. Optimize clock, power gate regs, PS regs. What about the power gate regs? Nah, those are just offsets, obviously. And the sort order wasn't the same either, so that also doesn't make a lot of sense. Unless there's a flag and it gets like allocated sequentially or something like that. And then it's this skipping business here. and 13. What are those things? Let's see. Doesn't make sense. Yeah, I'm thinking of going to the hypervisor pretty soon and seeing if some of the registers make sense. As the power gate registers should hopefully relate to the power domains. And also we have up to 3 of those, but we only have 0 and 1 here, which is also kind of weird. So I would expect this to be like the index into the power gate register or something, if that's what this is, but it's not. Doesn't seem to be it. So maybe it's just unused though. Well, okay, so let's go to the hypervisor and see how much sense we can make of pmanager. So trace AGX. PMGR. I do need to build the proper pmanager tracer anyway, because eventually there's going to be a lot of junk there, but let's see. Let's just do a better trace now and see if at least some of the numbers make sense. And then I need to build a little class to analyze this properly, because I also need to replace some old code in the hypervisor. We have this. They have this nonsense with pmanager hooks that are hard coding some of the clocks that we don't want the guest to touch. So this needs to be replaced with the proper thing. So this is a trace mode reserved. But for now, let's just do it like that. And I'll do that. Yeah, something like that. There's a lot of stuff already. That's the problem with the pmanagers. It's super spammy. And in this case, it's also writing because like the syslog and other garbage is in there. So I really only want to trace the first 2 blocks of pmanager, I think, or even just the first one. We have a trace device thing that only did a single ranges. Yes, ranges. Yes. I think the 0 is the one I want. Probably just 0 then, yeah. E70. No, there was some 1 business. PS rigs. Yeah, 0 and 1 are the only two that are going anywhere, so let's just do those. Let's untrace that. Trace that and continue. Okay, that's better. We still have a bunch of junk there. 7B7, 33. Definitely a lot of junk there that we don't care about. 7B7. Yeah. Fix the. Let's fix the manager. Where was that? Here. Unks. Yeah, 3B7 and D2, but B7 only goes to like there. And there's a lot of junk here that we don't need. So what I really want to do is go through PS rigs and kind of get everything there. But I don't know how far they go, though. Also, one interesting thing is that these are all sorted by address, even though these aren't, which is also kind of weird. Just, and we only want to do about something like that. Might help. Should be fine like that. range is not defined. I wasn't utils. I think. Yeah. It's unfortunately, error handler thing is annoying, but I was just reading that one actually, which is interesting. Some reason right there. 3F8 470 248. Basically just this. And they need the tracer thing. Says one core. That's what I need there. So basically, over here, so let's go through the table and trace all those registers, and let's see what happens. Actually, what I'm going to do is, for now, call this a print tracer thing. But then it needs the device address table, which is annoying. Well, it can go from HV anyway. Oh, we don't need that though, I think. I think you can just ignore that and say the address in your stable, that's the lookup, event address, yeah. ADT. And that's an ADT just here. Stream went blank. I don't think so. No, I think it works fine. Looks good to me here. Got the gates there. Build taper, just look up, and then it says range, and the node name, yeah. So what I'm going to do is I'm going to do it like this. I'm going to say starts is a thing like that, and so then what I'm going to do is start. First, I'm going to take both rigs in PManager. Header equals then address plus something like that. None. So we're going to build like a table of like non-overlapping ranges, basically. Though actually, I think the lookup thing can just do that anyway. Hold on, let me check and remind myself how this thing worked. Yeah, it has lookup all, but that's not actually what I want. I need a range map. It's not. need? What I actually need is a string, basically. Scalar range map is what I need, actually. Yeah, but then that's not gonna that's not gonna work for address lookup. Unless it uses the same API, which I can probably make it do, or just override that. Print tracer, or just honestly, or just not do this, just print it. Device address table, lookup, event address. Yeah, let's just not do that. It's easier that way. And then I can just do it like the proper way. So if I go to where am I? Utils, range map. Remind myself how this worked. Yeah, it just sets it. It's got ranges, and so let's go in like that, and then we can set the gates. And then gates. And then basically just trace everything in all the regs. I think this would work for me. So size like that will probably work fine. And then set this to .name. And then in event I just do it like this. And let's just do it with a and then it's got CB. Something like that, and then I can just say for this one, call it start something like that. And then this one would be some event gate. Oh, we can just say for now it's just event default, and it'll at least print the names of the things. And in this case, it would be let's go ahead and name gate. But I also want to have the PS regs and stuff worked out here. So in that case, because we don't have the lengths of those, I kind of have to guess there. Let's see. So let's just say these are sorted by, nah, that's kind of annoying. Reg equals 0, and are they actually sorted by address? Almost, but not quite. What about that OC one anyway? It's only one. Maybe that is the length, but then the ones that say FFF are kind of bullshit. It's only this 0 CPU 0 actually. It says gate 3, which also makes sense because gate 3 means wait, that's a weird mask. Oh wait, is that like the ones that exist? Because 8 is number, yeah, that's number 3. Interesting. Oh, okay. So mask is which ones exist then? Well, but then the ones that say 0 are kind of weird. PS reg 1, for example. It definitely has everything though. Maybe that's when there are too many of them, or something like that. So what about PS reg 0? But the ones that don't have gate 0, like this one, this 0B and that stuff. Yeah, it's only a few of them, right? So it makes sense. There's only like 16 gates. And the gates never go too high anyway. The gates never go higher than 31, so it makes sense to have FFFF as the max for that. Yeah. That does make sense. I don't know about the 0000 ones though. What about 6? Oh, that one has 2 gates. SIP and SIP EISP. But it only has a single bit. So maybe the mask is saying like a default state or something like that. The mask is some kind of information about what the gates do, but it's not which ones exist. However, that does mean that the PS regs are all 32 gates at most anyway, so I can probably just hardcode that. And in that case, basically what I'm doing is for this, it's calculated like this. PS 0 plus PS offset, and so basically do it like this. adder plus actually, let's just do it. Let's do it separately for each one. And default. And this would be PSI dot gate gate. And then the ones that actually have in devices, just do it like that. And then the power gate regs kind of sound like they are. You know, those are kind of interesting. They also have another mask. Oh, I'm getting a feeling that the unknown thing is the power gate register. Does that make sense? No, actually it doesn't. Or does it? I think it doesn't. Hold on. Unknown. No, it doesn't. Because it's only one. How about the clocks? No, but it doesn't work. Our domains. Because there's 3 of them and we don't go that far. Because that one only has like 15 or something. No, that doesn't make sense. Huh. Oh, but that flag. Oh, hold on. That flags thing smells like it's not flags. That looks like it could be a power domain register with the 3 there. I think that makes a lot more sense. Power gate and power gate reg, and the last byte might be flags for all I know, but that looks a lot more like it. Yeah. And in that case, like the CSV nom should be power gate like 224. That's a clock gate and a power gate, yes. Yeah. And 225 and 223. No, hold on. Wrong number. This is 312. Damn it, that again. Yeah, no, I'm pretty sure that's it. Okay, so let's do that first. That's not flags, that's the power gate, which also I think makes sense the way it's laid out. Merge devices, yeah. So in that case, flags would be first one is probably actually flags. Unless it's like a clock. It could be a clock index actually, or some weird thing like that. And then the next byte is the gate index, and the next byte is the... Or not, because there's more than one. 130, there's a 2 there, yeah. This kind of match. 2, oh, 5. That's weird, there's no 5. Am I wrong there? Things that go from 0 to 3. But then it needs like 31 bits for everything else. Hold on, let me... Five, 6, 7, 9, 30. Hold on. P manager. Oh, this byte goes 0, 1, 2, 3. That one is always 0, 1, 2. And then maybe like the Vmin and Vmax have something to do with that. And in that case, this would be the index. But there's a lot of the same ones though. ISP, SOC, SOC. It also doesn't quite follow. Oh, what about UNC2 though? Oh no, that was just the bytes. And that was always 0, I think. Is there an assert thing here? I think there was a thing there. Constant. Let's make sure that still parses. I think that tab really hated me. Less doing stupid stuff again. There's some horrible n squared thing and it hates the long lines. Does this parse? No, it doesn't. So that isn't actually const. Stump one. Oh, there is stuff there. Okay. Aha. There's multiple things there. Oh, that could be an interesting. Yeah, there's definitely stuff there that I missed. CBED. So that looks like 400. Looks like more bytes. Oh, this could be some of the offsets that I was missing, actually. That's what I get for not asserting that. Okay, so okay, there we go. Definitely something's going on there. So we have 420. So the lowest one looks like a 16-bit something. And then we have some other offset, and then hmm. 5, 6, 7, 8, 9 is kind of interesting to. Oh, I think to start with. Those are the CVUs, so that's some kind of CPU related thing. Only the CPUs have that. Then we have 25, 26, and 27. And EVC, whatever that is, was interesting. And then 10 there. So it looks like it might be a 16-bit value, then an 8-bit value, then another 8-bit value, then a lot of zeros. We have something that's hopefully always zeros. Constant 14 bytes there. These 4, and then another 4 bytes that look constant actually. And then 2 more, which might be just one 16-bit value actually. Then UNC 3. Let's see what UNC 3 is, because I think I'm also not printing that, and I probably missed more stuff there. Yeah. UNC 3, and then I need UNC 2. Okay. It's constant? No. Const. Okay, there we go. Now something is different here. Okay, 5, 6, 7, 8, 9, 10. There's a 1 there, whatever that is. A 3. 37, 38, 39 are interesting. Those are dispexts. And then 16 there. Disp 0 CPU. See all these V's, it should be the power gates, right? What does PMGR stand for? Probably power manager, but we don't know for sure. And this first one, yes, definitely related to the CPUs, because it's also in order here. There's 38, 39 there. Oh, those match. This picks GP0, 37, 30, 39. Oh yeah, those match, okay. I'm getting it somewhere. That's the only ones that have that, though. Is that coincidence, or...? So maybe this ID is not an ID. Maybe this ID is like a register offset or something. And then maybe this is the ID, because that would make sense, because these are incrementing the same as these, basically, so... So then it would make sense that these are indexes into the registers or something. So 0 has up to 32, which is a bit weird, because that doesn't make sense. If those are masks in the same way as the others were. Okay, let's get the power domains thing changed. Hopefully this is the ID, the B thing. Offset? No. IDA of unc2. Hold on. Off. Yeah, so this is the ID in this case then. Which is what I called off. And then also this matches kind of this this pattern here with having the ID at the name and then some weird thing, and then it's always 0, the unc3 thing. So is that always the same? Is that always 0 here? Unc3. Yeah, no, that does have stuff actually. So that should be, I should be printing that as decimal, because that might be another thing. So 3D or something. And in that case, what is that? Unc 3, 16, 17, 12, 5. That could be a clock. MMX is 17. That's one of the PLLs. Let's do one of the smaller ones. Venx's is 3. That does not match, but it's something, so that might be something related to the power gates. APCI is 16. ENS2 is 15. Oh, that might be the index into the power domain here or something. Not sure. 1 second, toilet. Okay, getting somewhere here. 12, 11, 14, 13. So those are, on 3 it's 14, 17, 16. This text FE is 12, which does not match any of those. At least this 37, 38, 39 looks like it matches something there. The clocks. And then I got that backwards because I got ID, clock ID, AV Unc. Wait, is that the same? Sorry, sorry. Power domains would be ID. Oh, do I have two IDs now? That doesn't make any sense. AB Unc, AB Unc 2. Those are the only ones that have a field there, which is funny. 37, 30, and 39. They definitely match the power domains, but come on. And probably the clocks are the same thing here with the ID being B. Let's call this A and B. Yeah, that makes more sense. And these always 0, hopefully. We have clocks. Yeah, those are always 0, so let's just do it like that. Two. Yeah, it's fine. And this one is also always 0, I believe. Or no. UNC3. Oh no, we do have an UNC3, sorry. That is something. And power domain UNC is always 0 also. So let's just make it constant. So clock by ID. Probably going to need that one. Hopefully going to find that one. So let's see if I can find the clocks now. Those go from 1 to 27. Could be that previous one. ECPU 5, 6, 7, 10. No, that does not match. Any. Not quite there. This picked ones are definitely correct. 7, 38, and 39. It's funny how this is also off by 1, but I think that's a coincidence. So 3, 1, 2. So in this case, it's this one. 2, 1 is clock, I guess. Power domain, sorry. If read the index. Let's call this gate. PS, I don't need the index stuff. id.name. Something like that. Something like that. Do all that stuff. Okay, that makes sense. Probably want to put it afterwards, though. And then what about the clocks? Fifteen, 16, 17. I think it's time to go back to the hypervisor and see if I can make sense of some of this. Okay, hypervisor, manager, hinges, gate. Yep, it's another session of what's this random field indeed. PS reg, gate, do I have this? Gate or PS reg, then set that up, and then I also need to get the other registers, which I don't know if the gate regs thing is kind of an unknown too. But hopefully this will tell us something. Gate regs. I'm assuming my interpretation of reg and offset there is correct. It sounds reasonable. And I guess just give it 32 regs off of that, probably. Gate regs, was it? Power gate regs. Get reg plus PS. PS PG. Yep. PG. Well, I'm going to use the hypervisor now to see if I can make sense of this. PG.reg, PG.offset. And then, yeah, I guess just do another gate thing. And PGI dot, I don't know, whatever, probably gate. Let's see if that makes sense. I probably want to run this. Measure.txt, update that. And can I run that? No, tracer. Any trace manager is not defined. It's just dev or something. Street error PS reg PS reg. It's not dev.ps reg. Where is that? Oh, because I have. Oh, that is correct. So the devices that PS reg just PS 80T. Oh, because this is already parsed. It's gonna break. Because I renamed things. Let's redo that. And that did not work. Trace takes 4 positional arguments, but 5 were given. Not self. Okay. That is some random crap. That's a lot of random crap. That is not working properly. I shouldn't be doing this at this point. I think that's not working. Is this actually working? Let's see. 044. Is it working or is it? That doesn't look right. Oh, I didn't add it to the HV or something. No, it should be. Oh, it wasn't MMIO. Hold on. That's from print tracer. Oh, is that a special thing? Yeah. That's why I'm not doing the add tracer thing. That's why. Hold on. Forgot the print tracer is kind of special. And that already does the default thing. It's just that I need a handler that comes from the reg, but if it's not a reg, it's not a verbose equals 1. Yeah, so we don't need that as a reg. So what I actually want to do is override RW. Uh-huh. Like that. Okay, that makes more sense. UART 4. Bluetooth stuff, I guess. I don't know what 3F8 is and why. Oh, that's... Oh, we have 3F8 in there somewhere. Lisa streams some of her GPU stuff on Twitch, I believe. Not always, though. Okay, 3F8 is not actually in there, which is interesting. But it's definitely getting read. And somehow related to PS12 gate 28. Which is like right before that, actually. Just weird. It's also not listed. That is very spammy. There's one with the override 420, which we do have. That's the CIO USB. Yeah, so that makes sense. Oh, that is. Okay, so let me do something interesting here. If I go to RW and then AG shell, run shell. Oh, right, this is async. We go to sync then. Yes, because it's just because it's queued. Okay, let's just be manager. But then CLPC v3, interesting. So the LPC was a thing in the ADT. Did this just die again? I hate it when it does that. Okay, let's scroll back. Scroll back. Yeah, so this is probably CPU related, which makes sense. Oh look, there's some devices thing here. 7, 6, 9, 8, yeah. Let's add that to the ADT list anyway, that's useful. And this device set thing here also sounds like related. And I'm gonna need some freaking regexes here, aren't I? Or at least a glob. I think that's a thing. Easier than regexes, or not. Essential X? Or is it? Oh, it's just glob, okay. Not path names. I just want to know. Was on a match, FN match? Yeah, that's what I want. Uh, yeah, so it's basically special ones. Devices, device bridges, device type, devices, devices. Yeah, so basically CLPC and sock tuner. And then in that case, basically, def prop is good. Let's get that name, def props. So something like that. And run that again. That did not work. Regulatory model. That what? Is not items. The range has no len. Sorry. Okay. Okay. Bleh. PT or something. There we go. That is not working. Device set star. Why is that not working? Sock tuner. That one did work though. CLPC did work. So the match isn't working. My device set star. Did I get the fin match backwards? File name pattern. Yes. It's name K. I did get it backwards. Yes, and then MCC configs should just be a greedy range. Again. CLPC events is also a random thing. Yep. And those are probably also from the events list that we saw in that thing. What's PPM? Oh yeah, that was the power management thing probably. And PMGR has the voltage states thing too, which is also interesting. Those might be related to what we're doing actually. Because they have yeah, all of those actually. 02951.811. Zero 295 basically. 89. And that function perf boost thing is also kind of also, what is clusters? Sounds like it's also, yeah, a list of and I kind of want to make function something be just it starts with that. So yeah, it's actually the functions are always some kind of index, which is probably a reference to the, yeah. So basically, let me just get the function thing done real quick because it's kind of annoying. I just got function struct. I think it's a p handle. And then it would be a 4cc, which I did have somewhere already defined. Yeah, this kind of thing, but it's kind of annoying though. I guess I'll put this in utils or something. Uh, this makes life a lot easier, hopefully. That's 31. Okay, export adapter. I need to import that. 4cc. 4cc from that. And then actually use it. And not quite getting there. As of now, does the kernel boot up? What do you mean, like Linux? The kernel has been booting since like February or March or something. Path parsing, exacted. 450 function bootstrap lock. The hell is that? Oh, that's just the name. That's kind of annoying. Then I guess for function, I'll just do $32UL. Otherwise, there's the function. Actually, no. Yeah, that makes more sense. A little bit nicer then. So, what are the main problems still have to solve except display ones? All the drivers basically. So we need to get the display controller to work, the external display controller to work, the GPU driver, the USB like 3 and Thunderbolt, audio. There's lots of things to do. Manager bridge counter. What states to. Let's make voltage states for now a greedy range to see if that makes any sense. That didn't work. Why didn't it work? Oh, because it's like that. Yeah. Looks like they're pairs, probably. Or something like that. Looks like it's... Okay, they're kind of different. Because these are obviously some kind of clock frequencies. Clock frequencies or voltages, actually. That makes more sense. That looks like clock, comma, voltage or something like that. In millivolts, probably. Except that. Okay, that's just null. So let's do it. Nah, I don't feel like using tuples. This is good enough for now. This goes to like 3 gigahertz. And then this is going down, just almost like it's not a clock, but like a clock period or something. I wonder if there's some weirdness going on with those values. Yeah, they're obviously pairs, but what I mean is that I don't understand why these aren't. These are clock frequencies, pretty obviously, but these are weird, and they're going down, which doesn't make any sense. So I wonder if this is some kind of encoding for a different, for maybe for clocks that are too high or something. Because this is getting close to the limit for 32-bit integers. So, but anyway, now I want to know if this makes like since like the GPU IGX or SGX would something like that or graphics whatever has one of these has a reference to this, or maybe under clocks or power domains. Well, power domains doesn't make a lot of sense for this. Look, that 5 could easily be that voltage states thing, because that makes sense. That 5 is the PCPU, and then eCPU is 2, which we did have, I think. Yes. So it's one of those weird ones. Oh, probably because then probably because for the eCPU the voltage doesn't matter; it's always fixed or whatever. Oh no, sorry. That's the other one. That's the voltage. That's not the. Okay. But still, that still makes some sense. And then what else do we have? DP1 SOC VNAX. That's 1. Interesting. That's one that goes pretty high. But I wonder DP1 DisplayPort. Maybe something else. Let's see what else we have. And then we had an 8. Actually, just look for a 08 in here. We don't have that though. What about 11? Oh, is it the UNC? No, that doesn't make sense. I don't know if there's a way of getting the current voltages. I don't think so. There's probably some way of getting the like clock frequencies, but 2.9 9. Not quite. bypass caps around the core. I mean, yes, but I'm trying not to take the thing apart just for this. Still, though, that flags. This thing smells like voltage states to me. Oh, so this is a typo. It should be Vmax pretty obviously. And that says 102, so I bet that's voltage states 1, like index 2, or something like that. So this looks, what it's probably doing is it's setting it's setting like the voltage state for the socket or something, right? So like depending on which blocks need power at any given time, that will require a certain voltage for the whole socket or something, right? So that's one of the ways they save power. And then like that's why you have like Venc fast is like state 1, and then Venc stock Vmax is 2. So like Venc needs that much voltage, right, on 1. And then we have a 2 and a 5. The eCPU is 2, which is, yeah, it doesn't have the clocks for some reason, but it does make sense that it's there. PCPU 3, that one. And then the actually, do we have the clocks? 3.2 it says. This is just 3.2. Haha. So this is the thing apparently. Power metrics says CPU power. Interesting. So that is a thing. Hold on. I don't want to boot macOS on this thing right now, but I'm going to try it on the laptop. So I've got the MacBook Air here. But yeah, anyway, we had a 3.2 in there, pretty sure. And that, yeah, this thing here. So 5 is obviously the PCPU, and it does match. So I'm pretty sure I'm right on that one. And that is the voltage state. And the other one is the index into that. So in that case, what we have is, any of this was in flags. Something which we don't know. Let's go on 0, and then it would be the index, and then probably const 0 into eval. So I don't think there's anything there. The set, I guess, voltage set. That did not work. Terminated error. Oh, sorry, I'm done. Flags goes away. Yes. And then in dump p manager, instead of flags, it will be APS reg. It would be dev.v index. Does it look like this? Is there a 0 though? There is a 0. That's weird because again, it's like, does that even? Is there a flag for that? It might be a flag for that. Let's just print it for now. Ooh. There. And I also need Unc0. Again, running out of space. Sorry if you can't read it. I have to maximize. I didn't F that. And probably get 2D in there, or 3D even. Well, that's clearly some kind of bit mask or flags or something, though, I think. 16, 16, 17, 80. Yeah, that doesn't make any sense. That's, yeah. So volt 1 is the sock voltage, obviously. And volt 3 is DCS, whatever that is. And then we go up to volt 5. Ah, it's the sock. Interesting. Let's get all the ones that have voltages that are not 0. This is 1, 2, 3, 5. 2 would be eCPU, 3 would be DCS, and 5 is PCPU. And we don't know about 8. That's kind of weird. Just SSH into this. Oh, it's not turned on. I hate how like macOS likes to disable SSH whenever it feels like it. Why did that happen? Did that reinstall? I probably reinstalled on this machine. Not sure actually. Oh wait, no, this is a new install. That's why. Yeah, sorry, I just reinstalled macOS for a test on this, and I'm booting into the wrong install. But anyway, hopefully that works. Let's go back to this. So, okay, we're getting there. Unc0 is starting to sound like some kind of flags or something at this point. See, it works. So that is slow. Okay, well, now you saw how that worked. Ah, there you go. It even tells you the power and stuff. That's pretty cool. My machines are named after different things depending on what machine they are. The M1 Max are named after Star Twinkle Precure characters. My main workstation is actually and my main sort of home computers are Battlestar Galactica ships because I named it way back when I was watching that. And when I transplant an OS into a different hardware, it keeps the host name, right? So Raider has been, at least 4 or 5 different machines now, but it's the same install. Yeah, so it even tells you, the possible speeds on the E cluster. It goes to 2064. So it means that 1 is the E cluster, actually, which makes sense. But that is not matching these things, because this says it's stock, and then eCPU says it's 2. Unless it's like a reference or something, which it might be. Unless this is the voltage ID, which it might. Because then this would be 5, which we do have. And then eCPU, but then it doesn't make sense though, because the 2 there makes sense. The PCPU of the 5 there makes sense for PCPU. It doesn't make sense for SOC, so that's not right. 6972. Oh, there's more of them here. Yeah, so this one looks like eCPU. There could be that it's a reference, though. And then the other one is 600-828, yeah. So obviously the 5 and the 1 here are the main CPUs. But then for some reason it doesn't really list them like that. And it doesn't say the voltage, right? Just the speeds. And by the way, this is why this thing lasts forever in battery, right? Like the thing is turned on and it's using 24 milliwatts of power apparently. You really got their power management nice. Nicely done. Also, it likes to yeah. Can I get more though? Can I get yeah, I can get GPU power and stuff. That might be useful. So for me, what's presumably average over 5 seconds, I would assume. Is it space separator or what is it? Some comma separated, yes. Do battery, CPU power, devices. That's useful. Thermal, specify GPU power, and should be possible if I get all this PMGR stuff figured out. GPU power 0 milliwatts. Oh, I guess I am not doing anything right now, so it's on a static screen. Yeah, see now it's like 1 watt because I actually have the thing. That's the thing is, right? Before it was like 20 milliwatts because the screen was off, which means there was no screen refresh and no, almost anything happening. Now it's like 1 watt because at least it's on. And the DRAM power and stuff. So interesting. So what's this? States. No battery and backlight usage. Okay, thank you. Milliseconds per second. Yes. So let's run that again, and then turn the screen on, and that'll probably make some of those states not be all equal. Or not. That's not terribly useful. I don't know what those power states are, to be honest. But we know the GPU goes to 1278, which is 9. So the GPU is 9. GPU is 9, but then it has an 8 there. 1278. And then what is this? That goes to like 1464. Wonder what that is. That 8 one. Maybe it's the RAM. That would kind of make sense. It didn't have the RAM. It was not one of those things, was it? Bandwidth, maybe? Oh, these are. I know what those are. Aren't those these are in the ADT. Those are those things. Events. Yeah, that's what that one's that one, isn't it? Or not? No, counters or something, was it? The energy counters, maybe? No, this is something else. But I saw the RD and saw that. Bridge counter config, that's what it is, yes. M0 read. Not quite, though. Oh, close. And not exactly the same thing, but it's pretty close. ATC, M0 read, and it's like there's a certain replace going on or something. or I'm just on a different version, which is totally possible. Because this Max is on 11.4, and I'm on. Hold on. Let me just do a quick Apple OS 12 beta 5, which should be the. Sorry, actually, 11.4. I think is where I am on this one. Yes. So hopefully that's the same. And device tree, and this should be. That's the other thing, is the laptop can be different too. What device is this? The Mac Mini. A313AP. No, it's still M0 stuff. Still, though, this is clearly related to this. I do want to know what DCS is. I've seen that a few times. But that's not quite what I need here. Yeah, so that is in CLPC, and let's just continue running this. So let's skip those things, because they're kind of annoying. And trace P manager. Power of, oh, okay, yeah. I think because of the time difference or something, it calculated something like, a few gigawatts or something of power happened. I think something broke. Oh no, it's still running. It's not really doing anything. Oh, there we go. It's reading stuff. Let's open up the HDMI. Oh, it did boot. Okay. So, like, for example, can I trigger things to power on by doing stuff? I'm surprised it's not doing much more, though. That's kind of weird. Also, I probably want to bypass those. I feel like it's slow because of. I'm not sure actually. Might be okay. Let's see. Something that might be evident. It's not really doing much, which is pretty surprising. Because like it needs to do the CPU stuff too. So why? It's also possible that the Mac Mini doesn't aggressively power manage as much as the laptops, though. That's totally possible. What is it doing now? The stupid network thing, I think. What the hell is it doing? Did it just actually, like, die somewhere? It might have. I might have broken something. Okay, let's kill it and try again with the filters from the beginning to see what the whole log looks like. There's bound to be more interesting stuff in here anyway. Oh, but now did I change some of the names? I'm not sure if I broke anything. I think I didn't. Okay, see, there's definitely stuff going on there. Yeah, so the first thing it does is it reads everything. Including all of these that we don't know about, which is interesting. But it seems it just reads the whole set, apparently. So that's okay. Oh, is that what the mask is? That might be like the what to read mask or something. Let's see. Uh, I kind of broke things, I think. Yeah, I just broke it. But we got somewhere, so hold on. Back to that. Starts off at 100, which is interesting. Which, and it reads almost everything there. Oh, hold on. The gates are every 8, not every 4. Ah, yeah, okay. So for starters, I'm doing this wrong. Did I just calculate it? Yeah, sorry. And then P manager. P manager. Dump P manager. Also times 8. So 3F8 and 417 now might be something we actually know about. Aha, okay. So that is graphics, and that makes more sense suddenly. And 470 is A&E. Okay. Sorry. 3F8. Yeah, okay. Not the multiple parents thing. I'm just looking at the whole power management thing, which is more complicated than it might seem. So, okay, so this makes more sense. And now the numbers actually match what I expect. Yeah, so you can see how eCPU 0 is the only CPU that's turned on right now. And ECPM, whatever, like the cluster manager or whatever that is. So that's cool. So what I'm going to do next is only log writes, because that's more interesting. And see what it does. Just broke that EBT adder. How did that end up there? Doesn't make any sense. Oh, I was going to untrace those. Yeah. Cool. So I did a bunch of stuff there. And pretty much everything is things I know about. Okay, that makes sense. Yeah, so the very first thing PMGR does is basically turn everything off that doesn't need to be turned off. And I bet that has to do with the mask. It's probably the, what are you allowed to kill initially or something mask. I should look at that. Not that dump that. Yeah, 58, look at that. So it starts at 58. First this 8,000 thing, which is, and then 158. Yes, D2 is PS0 gate 0. Yes. And then that's PS1 gate 6. So I'm not sure what that's about. But I think starting here is turning on gate 0, and then it goes on until C0. So how many gates? 1, 2, 3, 4, 5. Oh, it's skipping some though. And it goes until C0, which is minus 58 is how much? 14. Yeah, and that should be 14, exactly. Yes. So that's the mask. And then it goes to 218. So it did skip some there. But probably things were already turned on though. But then it should do like 32 over that. And then in the 300s, it should skip like the 380 somethings or so. Yeah, look at that. It goes to 378. It's B, so it's 1011, so it skips the previous one. Yes, 370, and then it goes to D. Yeah, so this mask is that. It's basically the what are you allowed to. It's actually what it's doing is it's turning them on actually. So it's actually what to turn on startup, I guess, because this is all turning things on. And then there's the dangerous write. then it turns something off at that point. It tries to do 420. Which is one of the... So it is turning that one off, which is interesting. Oh, yeah, it is turning some of them off. Like this one, ATC1 common. Is it only turning things on, though? Oh, no, it is turning some... Oh, it turns that off and then on. Oh, yeah, it is turning something else. The guys could see and stuff. Ah, okay, so then it turns things off. Some things. Don't know what that one is. C0. You saw the names match now, so that's cool. And let's go C stuff, SPI stuff, yeah. MMX, whatever that is. That's interesting. Is it booted yet? Yes. And it turns off this text because I don't have anything plugged into the Type-C port that is a display. Maybe this. But the interesting thing is that I'm not seeing any other I/O except the gates, which is a bit confusing. Unless I missed something here. And I think turning it off and on is just initializing things. For some reason, it like the code does that. But I don't think it's a self-test or anything. Yeah. So there's one that we don't know about there. PG. Oh, look, there's power gating registers there. There's some stuff here. Okay, yeah, there is some stuff. The one if when there's some gates we don't know about here. Why actually? Like 0, 1 F8. Is this before I? No. 1 F8 should be mapped. Why isn't it? Did I actually get this right? I think so. Oh no, it starts here. Okay. Yeah, so it starts there. A lot of spice stuff. Yay. This is all this is all too simple. So now I'm wondering if because like okay, CPU power states, but it's not even writing to those registers, right? So what's going on? Or is it a different entry? Okay, at least it's not hanging right now. So is it gonna do something if I what should I open? Something that like a video decoder or something like that might work. But I don't know if I could try to go to YouTube or something. But does this come with any videos? Let's see if I can find any video files that are in the system. Yeah, there's some GarageBand things, I think, and crap like that. So let's go to... Is GarageBand installed here? Probably not. Setup Assistant might have that. System Library Core Services. Let's just do it from the SSH. I think that's it. Yes. And System Library Core Services, Setup Assistant, the app, contents, resources. Yes, the video decoder got turned on. So it is working. And also clearly MMX is related to that. If I quit it, it gets turned off. So yeah, obviously it's working, but I'm surprised that I'm really only seeing a few power gates because I was expecting a lot more. So now I'm wondering if that power management firmware is doing all the CPU stuff, which is very likely, I think. That we don't actually need to deal with any of the other registers, so it's really just these clock gates, which would be very nice. But now I wonder, because like Kernel has this driver with the CPU frequency changes, and I think it was using P100 registers. So let me do a quick look on that, actually. It was in here. And actually, I want to run that system thing again. Power metrics, CPU power. Sudo. Segmentation fault. Well, that's lovely. Is this like a 12.x bug or something? that is well, okay then. Well, I guess we're not oh, I know why it's happening. Probably because this only has one CPU in the hypervisor, and it probably hates that. So I might need to enable multi-CPU. That's also possible that like it doesn't support. It's not even trying to do CPU power management because it only has one CPU and like it doesn't like that. In principle, it should be able to do that power management for that one CPU, but maybe something failed somewhere and they just gave up on that. But that's a bit of a problem now because I want to find out how that works. Still pretty surprised by how little traffic there is in here during normal operation. But okay. So maybe check one more thing. Yeah, let me just make sure. Linux, I think had that in here. Driver CPU frac. Apple M1 CPU. Yes, this thing was using. But it's probably one of those. Okay. HCC. Maybe it wasn't pmanager. HCC came from. That's pmanager base. That's 4 bases. P manager is the second one, MCC is the third one, then probably the clusters are the first two. Okay, so it's probably a different place then. But the P manager, CPU, TVM, is what? It just enables something there. Okay, so that's it only does it once. And that is... This is the CPU gating. At 48C, yeah, but those are larger addresses. Okay, so that's why I didn't get anything, is because I'm not snooping on those addresses yet, so that's fine. And the PS info then is probably in a different place then. CC base. Yeah, it would be the cluster presumably. Yeah. Yeah, okay, so that's right. It makes sense that I didn't see that. But then the other thing is I barely saw any power gates. Yeah, I barely see any power gates. 15, 14, 6. Yeah. So does that match any of the things we had in here? Hold on. Just log out of here. We have 14, 16. Okay, so then that looks like power gate to me. Because we go from here. That doesn't quite look right. Or is it? Gate 18 and gate 19. I'm not sure if that's the right place or not. No, it starts here, right? Yeah, okay. There we go. So it's PG1, gate 6. CPU1. And then we have, let's see, 14 and 15, which are ENS2 and SBR, maybe? Unless it's E. And I need E space, unless it's that, which it could be. And F. AOP, not quite, but maybe. So we only have those, actually. It's also really only touching a couple of power gates. Starting here. Yeah, it's literally only these. Okay, 14, 15, and 6. And the only thing it does is turn them on. There's very little going on in that case. Well, this is going to kill it, but let's see if I sleep how much I get before it dies. The answer is not much. Oh no, there's some stuff. Okay, yeah, definitely does a lot of things there, and I think now it's when it dies. Aha, now it died. But yeah, it's mostly the clock gates. There's almost nothing with power gates. I'm not even sure if these are power gates the way it kind of is laid out, so. Because these things are 1CO10, 310, 610. Might be, but it's not clear. And it's always this number too, which is kind of weird. Anyway, I think that's enough for today. I figured out most of these structures anyway, most of the interesting bits. And I need to get some dinner, so see you around. Next time I'll actually go get the thing upstream. But basically, since I've mostly determined that there's not actually that much more to do with P Manager than clock gates, at least in these address ranges. I think the clock driver design I have is basically sane. Just might check a bit of the dependency stuff from the hypervisor log, but we'll see about that. Okay, see you.